Welcome back to The Explainer. Look, we're skipping the usual intro today because we've got to jump right into a massive, stubborn fitness myth that has literally confused people for decades. We're going to break down the absolute physiology and anatomy of belly fat loss, looking at exactly how your body stores and, more importantly, burns energy. So let's start with the big one. Can you actually crunch away belly fats? I mean, we've all seen those late night infomercials pushing bizarre ab gadgets, right? Or, hey, maybe if you've personally spent hours doing endless sit ups just hoping to carve out a flat stomach and burn away that layer of fat sitting right on top of your abs. Well, the definitive answer comes down to one number: 1,100. That is the number of people involved in a massive 2021 meta-analysis covering 13 different clinical studies. And the hard science? It absolutely proved that spot reduction is a total myth. The data clearly showed that localized muscle training, doing hundreds of crunches, has exactly zero effect on localized fat deposits. Doing an exercise for a specific body part simply does not reduce the fat in that specific area. No way around it. Okay, let's dive into this. Here's our roadmap for completely rebuilding your understanding of belly fat from the inside out. First, inside your belly fat. Second, the science of fat burning. Third, how exercise shrinks fat. And finally, diet, hormones, and fat loss. Section 1. Inside your belly fat. Let's look at the anatomy of the abdomen. Now, your belly isn't just one giant, uniform blob of fat. It's actually made up of highly distinct, sophisticated anatomical layers. Right under the skin, you've got the superficial adipose tissue, or SAT. Then, right below that, dividing the space, there's a fibrous membranous layer. And finally, tucked underneath that one, sits the deep adipose tissue, or DAT. Now, what's really interesting about this is when you zoom in on a microscopic level, there's a stark difference. On the left, you can see the superficial adipose tissue is made up of these visually distinct, well-defined, super round fat lobes. But check out the right side. The deep adipose tissue has a much flatter, almost stretched out kind of structure. They literally look and behave completely differently under a microscope. And beyond just those mechanical layers, your body actually has entirely different functional categories of fat. To put it in everyday English, white adipose tissue is basically your body's energy bank. It stores lipids in a single large droplet, just waiting for a rainy day. On the flip side, brown adipose tissue acts way more like an internal furnace. Instead of storage, it uses numerous small lipid droplets to actively generate body heat. When we're talking about belly fat, though, we are almost entirely dealing with that stubborn white adipose tissue energy bank. Section 2. The science of fat burning. Let's talk about cellular withdrawals. Which brings us to an absolutely crucial biological definition: lipolysis. Technically speaking, lipolysis is the catabolic process of breaking down stored triglycerides into free fatty acids and glycerol. But honestly, the easiest way to visualize it is just making a withdrawal from your cellular energy bank. It's simply the process of taking that stored fat and breaking it wide open to create usable fuel for your body. So, how does this microscopic withdrawal actually happen? Well, step 1, a biological signal arrives. This is usually from hormones that get triggered when you exercise or fast. Step 2, inside the cell, those stored triglycerides get broken apart. And step 3, the resulting free fatty acids and glycerol are pushed straight out into your bloodstream, where they travel to your muscles and organs to actually power your movement. But, your body doesn't just hand out this energy for free. It actually has a super strict microscopic security system in place. Proteins like paralipin basically act as armed guards protecting the fat cell vault, making sure the lipids don't just leak out. Meanwhile, specific enzymes, specifically ATGL and HSL, act as the bank tellers. And here's the catch. These tellers will only go into the vault and hand over the cash, the energy, when they are authorized by the exact right hormonal signals. Section 3. How exercise shrinks fat. Let's look at the exercise effect. So exercise basically acts as the ultimate key to unlock your fat cells, using a massive cocktail of hormones and peptides. When you work out, catecholamines, which by the way is just a fancy science word for adrenaline, flood your system to stimulate lipolysis. Peptides called ANP spike during physical effort. At the exact same time, your working muscles secrete signaling proteins called myokines, like IL-6, which literally talk directly to your fat. And the absolute best part? You get this massive post-exercise recovery burn, meaning your body keeps drawing on that fuel long after your workout is completely over. And this brilliantly illustrates one of the most mind-blowing discoveries in modern exercise physiology.
Research shows that contracting skeletal muscle can release substances capable of remote signaling to organs during exercise. I mean, really think about what that means. As you're working out, your contracting muscles are literally sending chemical text messages across your body to your fat cells, telling the guards to step aside and the tellers to hand over the energy. It's incredible.
This cellular crosstalk is exactly why the type of exercise you do matters so much. See, lower intensity steady state cardio relies on burning fat during the actual workout, but high intensity interval training, or HIIT, it creates a massive nutrient competition inside your body. Because HIIT is so demanding on your muscles, your body powerfully redistributes the nutrients from your next meal straight to your recovering muscle tissue. It essentially starves your fat cells after the workout by prioritizing muscle repair instead.
Section 4, Diet, Hormones, and Fat Loss. The unbreakable lock.
At the end of the day, the undeniable, fundamental physics of weight loss all come down to the energy homeostasis scale. On one side, you've got energy intake. That's the proteins, fats, and carbs you eat. On the other side, you have energy expenditure from physical activity, diet-induced thermogenesis, and your baseline basal metabolic rate. Look, if the intake side is heavier than the expenditure side, the bank is just going to keep hoarding deposits, period.
So the crucial point here really comes down to insulin. Insulin acts as the ultimate unbreakable lock on the fat cell vault. When your insulin levels are high, which happens typically after eating, especially carbs, lipolysis is completely blocked. The tellers literally go on break. But when your insulin drops, like during fasting, between meals, or during exercise, lipolysis naturally ramps up and the vault swings open. Because here's the absolute truth. No matter how many chemical text messages your muscles send during a workout, you simply cannot unlock a vault that a high insulin diet has securely bolted shut.
We've busted the spot reduction myth, examined the actual anatomical layers of belly fat, met the molecular bank guards, and decoded the chemical text messages your body uses to burn energy. All of which brings me to a final, pretty provocative question. If your contracting muscles literally have the ability to talk to your fat cells, what is your next workout going to say? Are you going to send the powerful, high-intensity signals needed to finally unlock that vault?